We want to look today to find how to find the sum of a finite arithmetic sequence. You might also hear this listed as just a finite arithmetic series instead of the sum of sequence. You could use series or the nth partial sum of a sequence, something along those lines. Our formula, we have a formula for this, is S sub n equals n over 2 times the quantity of the first and the sum of the first and the last terms. In this case, a sub 1 and a sub n. I've also seen this written another way. Really, it's the same formula. It's not different in terms of what it is. The difference comes in where you place the 2. You could take and put the 2 here instead. Now, what difference does it really make? None. But perhaps it makes a difference in the way you think about things. For instance, this would take n terms and multiply it by the average of the first and the last term. This would take and add together the first and the last term and decide, well, if you added together the first and the last term, you have half as many terms overall. Either one of those would work to find the partial sum of a arithmetic sequence. Let's use that to find this sum. Now, I fully believe that you guys can add together all these digits, but let's take the time to recognize that we have 10 digits here. So if we wanted to use S sub 10, we could go 10 divided by 2 times the sum of the first and the last of terms, which would become a 5 times a 22, and the sum of these becomes a 110. Like I said, if you think about this real quick, we could add together the first and the last term and get 22. What you also might realize is if you add the 4 and the 18, you get a 22. The 6 and the 16 is a 22. The 8 and the 14 is a 22. And of course, the 10 and the 12 is also a 22, trying to match those up in pairs there for you. So you realize that we have 5 different 22s, if you will. And that's how that particular formula would work. The other method of doing this that we mentioned would take the average of the first and the last term. And if we thought of things that way, we could say S sub 10 is equal to 10 terms times 2 plus 20 divided by 2. Well, 2 plus 20 is 22. 22 divided by 2 is, of course, 11. And that gives us 110 once again. Not a surprise that we get the same result. But if I were to look at it this way instead, I might want to say that these two terms here average to 22. Okay? Likewise, I might say that these two terms, average to 11. These two terms here would average to 11. So that's instead of having a 2 and a 20 and a 4 and an 18, like having 4 11s. Okay? This one as well. What you find in doing it this way is if you do end up with an odd number of terms, that middle guy is usually the average guy anyway, so you don't end up feeling like you have half a term. When I think of doing it this way, there's the possibility, if I have an odd number of terms, that I might have 5.5 22s, which just doesn't seem to work as well for me personally. Let's find the sum of the integers from negative 100 to 30. In order to do this, first thing we're going to have to do is realize that we already know that a sub 1 is negative 100. We already know that a sub n, or our last term, is actually 30. The tricky part is finding out what is n. Now, the common mistake here is to say, well, we got 100 negative numbers, we've got 30 positive numbers, but the truth of the matter is we also have a 0, which is neither positive nor negative. So n is actually 131 terms. Okay, so this would be considered a sub 131 now. So if we took our sum of our 131 terms, and clearly with 131 terms, you don't actually want to spend a lot of time adding them all up. It's nice to have a formula for that case. we could take our 131, we can take our negative 100 plus our 30 and divide it by our 2. So what do we end up with? We end up with 131 times a negative 70 over 2, or 131 times negative 35. Now, if you punch that into a calculator, you'll find that that is negative 4,585. Let's do one last problem in this video. One last problem. We want to find the 10th partial sum, so we want to find s sub 10. The problem is, we know we're going to have 10 terms. We know we're going to have divided by 2. We know we're going to have 40 for our first term. We know we want to add our last term, but we don't know what a sub 10 is. So we're going to have to figure out what a sub 10 is. Now, clearly we could go through the process of finding a sub 10 by counting out 10 terms, but if you recall, we can easily look at this and say, well, our common difference appears to be a negative 3. We're adding a negative 3 every time. So our a sub n formula should be the first term plus an n minus 1 number of common differences. So if we found a sub 10 would be a 40 plus 10 minus 1 common differences. Or in our case, 40 plus 9 times negative 3, which would give us a 13. So now that we know our 13 here, we can plug this in, and we'll end up with a 10 times a 53 halves, or 10 times 26 and a half, which is going to become 265. That's your 10th partial sum for this particular arithmetic sequence.